Hello students, I am Subhashish. We have learnt about sets in our previous session. In this session, we will learn some important topic, polynomials in algebra. Before going to the topic, let us discuss few points. Students, do you know what is algebra? Algebra can be thought as next level of numbers. Algebra is also known as science of determining unknowns, also finding of unknowns. Learning outcomes. After this session, you will be able to learn about linear, quadratic and cubic polynomial, to solve a quadratic polynomial, to find the zeros of a polynomial by using graphs, to find the number of zeros for different type of polynomials. Keywords: polynomial, linear polynomial, quadratic polynomial, cubic polynomial, graphs, points, zeros. Let us recall few important points about polynomials. Students, do you know what is a polynomial? A polynomial is an expression which consists of variables, constants and exponents combined with mathematical operations such as addition, subtraction and multiplication. The standard form of a polynomial is an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2 plus so on plus a1x plus an, where an minus 1, an minus 2, so on a1, a0 are coefficient of variables of x with different exponents. We have recalled the definition of polynomial, and now let us recall the degree of a polynomial. The highest power of a variable in a polynomial equation is called the degree of a polynomial. For example, the degree of a polynomial equation 2x power 6 plus 50x power 4 plus 3x square plus 60x plus 3 is 6. We have recalled the topics which we already know. Now we will learn about linear, quadratic, cubic polynomial graphs and to find the zeros of the polynomials. What is a linear polynomial? A polynomial with degree 1 is called linear polynomial. For example, 2x plus 4, 3 by 2 y plus 5, root 5 z plus 67 are all our linear polynomials. So, if you observe the equations, the power of variable is 1 in all the cases, and 1 is the highest power of variable, which is called degree of polynomial. Okay, now let us learn about quadratic polynomial. A polynomial with degree 2 is called a quadratic polynomial. For example, 8x square plus 9x minus 1, root 7 u square minus 2u plus 5, 3 by 4 y square plus 2 minus 4x square are quadratic polynomials. If you observe the polynomial as the highest power 2 and the name quadrate means square. Students, do you know about a cubic polynomial? A polynomial with degree 3 is called a cubic polynomial. The general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers and a not equal to 0. Example, 3x cube plus 8x square plus 9x minus 1 is a cubic polynomial. So, we have learnt about 3 different types of polynomials. Later, we will come across the polynomials whose degree will be greater than 3, which are simply called as polynomials. Now, let us learn about the zero of a polynomial. A real number m is said to be a zero of a polynomial p of x if p of m is equal to 0. This is also called as the value of p of x at x equal to m, and if m is 0, then p of m is equal to 0. For example, if p of x is equal to minus x square minus 2x plus 8, if we put x equal to 1 in p of x, we get p of 1 is equal to minus 1 square minus 2 into 1 plus 8. After solving, we get 5. Phi is the value of p of x at x equal to 1. The value of p of x when x equal to 2 is p of 2 minus 2 square minus 2 into 2 plus 8. By solving, we get 0. Also, p of minus 4 is equal to minus of minus 4 whole square minus of 2 into minus 4 plus 8. By solving, we get 0. As p of 2, p of minus 4 are equal to 0, 2, minus 4 are zeros of the polynomial p of x is equal to x square minus 2x plus 8. Now, we will learn the geometrical representation of polynomials, where we can show the zeros of the polynomials using graphs. We know that a real number t is said to be 0 of the polynomial p of x when p of t is equal to 0. 0 of a polynomial is important topic. We will check why the 0 of the polynomial is important by drawing the graph of linear and quadratic polynomials. Consider a linear polynomial px plus q where p not equal to 0. The graph of y is equal to px plus q is a straight line which intersects the x-axis at exactly one point, namely minus q by p, 0. Therefore, the linear polynomial px plus q where p not equal to 0 has exactly one 0, namely the x coordinate of the point where the graph of y equal to px plus q intersect the x-axis. Example, draw the graph of a linear polynomial y equal to 3x plus 4 passing through the points 0, 4 and 1, 7. We can observe that the graph intersects x-axis midway between x equal to minus 1, minus 2. It is at the point minus 4 by 3, 0. We also know that the 0 of the polynomial y equal to 3x plus 4 is also minus 4 by 3. Thus, the 0 of the polynomials y equal to 3x plus 4 is the x coordinate of the point where the polynomial intersects the x axis. Now let us observe the geometrical representation of quadratic polynomial. Example: consider a quadratic polynomial minus x square plus 7x minus 10. That is y equal to minus x square plus 7x minus 10. Find the values of y by substituting different values of x. Let us take the table of values to draw the graph of the given quadratic polynomial. Now locate the points on the graph and join, we will get a graph like this. From the graph, we can say that the zeros of the quadratic polynomial are 2 and 5. Also, the x coordinates of the quadratic polynomial where the parabola formed intersect the x axis. We can observe that the quadratic polynomial forms a parabola on the graph paper. We can also say that the zeros of the quadratic polynomial are the x coordinates where the parabola formed intersect the x axis. Based on the above observations, we can say that the graph of a quadratic polynomial is a parabola. The solutions or the 0 of a quadratic polynomial depends upon the intersection of parabola with x axis. Let us look into it. If parabola intersect the x axis at 2 points, then exactly 2 solutions will exist. If parabola intersect the x axis at 1 point, then exactly 1 solution will exist. If parabola does not intersect with x axis, then there exists no solution. Now we will check the geometrical representation of cubic polynomial. Consider a cubic polynomial x cube minus 9x. That is y equal to x cube minus 9x. Find the values of y by substituting different values of x. Let us define table values for the cubic polynomial as shown. Locate the points on the graph paper. The curve intersects the x axis at 3 points. From the table and the graph, we can say that 0, minus 3, 3 are the zeros of the cubic polynomial. From this, we can say that a cubic polynomial has at most 3 zeros. Note, a polynomial p of x of degree n, the graph of y equal to p of x intersects the x axis at most n points. Therefore, a polynomial p of x of degree n has at most n zeros. Points to remember. In this session, we have learned polynomials are mathematical expressions composed of variables, constants and exponents, combined with operations like addition, subtraction and multiplication. The degree of a polynomial is defined as the highest power of its variable. Zeros of a polynomial are values where the polynomial equals 0, and these can be determined through graphical representation. Geometric representations of polynomials on graphs help visualize their zeros and how they intersect the x-axis. A polynomial of degree n can have at most n zeros, which is a crucial concept to remember in polynomial algebra. Thanks for watching.